Okay, when we left off yesterday, we had drawn, we had the zinc. So let's see, we had zinc as our anode and copper as our cathode. So we had Cu 2 plus 2 electrons. I'm trying to locate 2 electrons to give me Cu, and that was 0.15. And then we had zinc, and that was Zn, and we have Zn 2 plus 2 E minus. And on our chart, it was 0.76, but we flipped it, so it was positive 0.76. And is that those right numbers, or did I?
I think they are.
Did we do this one?
Copper and the 2 electrons would be 0.34.
Just electrons.
Oh, copper 0.34. Okay, so then it was 110 volts, and that is our E naught. Okay, so if I write this reaction and we write the overall equation, balanced equation, this is what it comes out to be. And on your next question, it says, what would happen to the potential if you increase your copper 2 plus? So if we increase, right now we're saying they are at 1 molar. So we have 1 molar solutions. What if we increase our copper 2 plus molarity? What would happen to our potential?
Okay, so we have copper, like you were just said, it's a battery. So copper is in the thing.
Copper's are supplying our electrons. It's the anode. If we add more copper, what's going to happen to if we're adding on to the reactant side, what's going to happen to our potential?
It's going to become negative?
Which way are we going to push? We're pushing to the right, which means what happens to our potential? Our potential is going to go up. Okay? That all goes down to Le Chatelier's principle. So you've got to be able to look at that and see if we increase or decrease our potential, what is going to happen. And we're going to talk about that tomorrow with Q. Any questions on that? So E naught would increase. So increasing Cu's molarity, concentration of Cu increases E potential. Not E naught, because we wouldn't be at E naught anymore. Yes?
I don't know how to write the equations from the given words. Like from the problem. I don't know how to write the equation.
Like, it just says a zinc electrode in 1 molar zinc 2 plus solution, and we have a copper electrode in a 1.0 molar copper solution. So then what we did is we go to our standard reduction potential table and we see who's the biggest number, and that we write that the way it is on the chart. And then we go and find the other one and flip it. Okay, so the next thing it wants us to do is it wants us to go ahead and kind of do like what you did on your homework yesterday. And we're going to do that right here. So we're going to do one where we have to write the equation, and we have one where we have already the equation written for us. So the very first thing, what are we going to do so that we can write this or draw this out. So this is something that you might see on the AP exam, but they won't ask you to draw it out. They'll have it there and they'll have you label it. So our very first step is to go ahead. We need to find, let's see, we need to do anode, cathode, the electrode material, half reaction at each electrode, ions in the cathode anode compartment and salt bridge, direction of electron flow, direction of ion movement, and calculate E naught. So lots of things going on. So first of all, let's just calculate E naught. So cobalt goes to cobalt 2 plus 2 electrons. Somebody go find that number. And we have 2 negative 0.28, but it's flipped, so it's going to be positive 0.28. Cu 2 plus and Cu, and that one was 0.34. Positive 0.34 volts. So our E naught is 0.62 volts. Once I've gotten E naught, I'm just going to go back and balance our equation. So since we have 2 electrons on each side, we can just go ahead and balance it out. Uh-huh. They are. They're posted. You want to go get that for me?
When are you switching to school? Are you switching all the way over to that?
It's from the sweatshop.
Okay, so let's go ahead. What do you guys want to draw first? We need to draw 2 cells. So here's a cell, and here's a cell. So what do y'all want to be in the first cell?
Cobalt.
Cobalt?
Yeah.
Okay, so let's just go ahead and underneath it and put cobalt's reaction, CO, goes to CO 2 plus 2 electrons. And then on the other one, we have 2 electrons plus Cu 2 plus goes to Cu. All right, so here we have in here some solutions. We have our electrode right here. So what is the electrode made out of? Cobalt, good. So that is our, go back, there we go. Cobalt.
We're going to use our reactant to be what the electrode is?
Yes. So, and then we have on the other side, we have a piece of metal in there. And what is that piece of metal going to be? Copper. So that is our copper. Which one's our anode and which one's our cathode?
The cathode is the copper.
Yes, and so our anode is the cobalt.
And why is that again?
It flows from smallest number to biggest number. And if you look, you see who's being oxidized and who's being reduced.
And being reduced means you gain electrons.
Gaining electrons, so we're reducing on the copper side, and we are oxidizing on the cobalt side. And then we have to have a wire connecting these guys together. So, oops, let me find a different color. Okay, so here we have a wire connecting them. This, we have a little like voltmeter in there. Or it can be a light bulb, whatever you want it to be, something that will show our electricity going through. And our electrons flow which way?
To the right.
To the right. So electrons are flowing this way. Please, if you get this question on the AP exam, show it that it's flowing through the actual wire and not flowing like this way. They've had that before and they would not take it because it's showing that you're flowing it through the glass. So they're assuming that you know nothing. So that's just go what we've talked about. What is the solution that the cobalt metal is in? 1 molar cobalt, 2 plus. And in the other one, we have 1 molar copper, 2 plus.
Wait, what do we do? Like, how do we know which one to put in the solution?
It has to be the same thing that what it is because it's got to pull electrons from some. So what happens is this is going to start losing mass and dropping off ions. And what's happening here is we have copper here, and it's going to start building up onto there and pulling ions from there. Okay, and then our last thing is we need a salt bridge. So you have to decide what are you going to make your salt bridge out of. So the problem with chlorine is chlorine always soluble? Because we want something that's not going to interact with our electrodes. So I would do NO3 and K. So I would do for your salt bridge any group 1 nitrate. And then which way are those electrons going to flow? Who's going to flow where?
Wait, electrons are, so would NO3 go into the anode? And
Yes.
actin would go into the cathode?
Yes. Okay, so our NO3s are going to flow this way to replace the negatives that are leaving, and our K plus is going to go this way to replace the K plus that is building up on the cathode. Have we forgotten anything?
Wait, so the copper is gaining electrons, so the K is positive, so it's going to flow to the more negative.
K is going to flow towards the positive, to the cathode.
Okay.
So the positive is going to flow to the positive. The negative salt is going to flow to the negative. All right, our next thing is it wants to know, we've done the electron flow. I talked about group 1 nitrates. We talked about what's being oxidized and what's being reduced. So who's going to gain mass and who's going to lose mass?
The copper gains mass.
The copper gains mass, so this is going to gain mass. So this is the fat cat. And then we are going to lose mass, and this will be our anorexic ox. Everybody good with that? Now, you need to know how to write the shorthand notation, instead of drawing all this out. So what we're going to do is we're going to put our oxidation, what's being oxidized, we're going to separate it with 2 lines from what is being reduced. So you kind of say run to the OR. All right, so you're running from O to the R.
Operation room.
So we put the metal, our cathode and anodes on the outside. So our anode is cobalt, and its solution is 2 plus. And it is running to the copper, and its solution is copper 2 plus. So that is the shorthand way of writing what we just drew.
Oh my goodness. Very short.
Good? Okay. Let's do this next one. We're going to do this really quick. Oops, went too far. All right. So this is one of those ones where you have to decide what's going on. So the very first thing I would do is go and find copper and iron on your, the Fe3 plus is not on the pink one. It's on our other one. No. So we know copper. We've done copper a while ago, and it was 0.34, right? And if you go to negative 0.04, and that we have to flip it. No. So now we find out which one's the smallest one. So the iron is. So we're going to flip it. So it's a positive.
Why didn't we flip?
Because we went from Fe to Fe3 plus.
No. So you go and you see what is the biggest one on between those two numbers.
So Fe has the smallest E value, therefore we make it positive.
It has the smallest E. We make it opposite of what it is on the chart.
We did not do that on the last one.
Wait, yeah, we did. Yeah, we did. Because cobalt was a negative 0.28, and we went back and made it a positive.
Okay.
So we have copper 2 plus our 2 electrons going to copper, and its number is 0.34 volts. We have Fe going to Fe3 plus 3 electrons, and its number is positive 0.04. So
if it was written the other way, like Fe3 plus Fe.
no, why did I put the copper? Because I don't know which one's the cathode or which one's the anode until I look at the standard reductions. And then the one that has the highest number is going to be the cathode. So then I have to flip the other one to get to the anode. Because we want this to run in a positive direction, right? You can't have a negative volt battery. Your battery's got to be a positive. So we have to get the one that's going to give us the biggest number. It's our cathode. Okay, so then our next thing is we're going to go back and we're going to go ahead and balance this. Multiply the top by 3, the bottom by 2. And overall, I should get 3 Cu2 plus 2 Fe gives me 3 Cu plus 2 Fe3 plus. Okay, so what do you got? We got to draw our two cells. So we have a cell here and a cell here. We have the solution. We have a salt bridge. All right, what do you guys want to be on the left side? Iron?
Onion?
So iron goes to Fe3 plus and 3 electrons. And we have our solid iron here. So this is Fe. In our solution we have what?
1 molar.
1 molar Fe3 plus.
And we don't have to write the modified one at the bottom, the balanced one, whenever we try to balance the electrons at the top.
No, I'm just denoting which one's which and what's going on.
So if we had this in the test, would we have to do this, put it on the bottom too?
If I ask you, if it says to do it.
As you wish. No, wait, wrong movie.
And the red thing is our iron. Which one's our cathode? Sorry, not our iron. Whoop.
Okay, I was like, dang it, I thought I had this.
Copper's the cathode.
Copper is the cathode, so that is our fat cat. And our iron is our anorexic ox.
Chris Pines slays my life.
Yeah, honestly.
Chris Pines, like his comeback was so good.
So now we have our wire that is putting this together. Which way do electrons flow?
On the wire. Through the wire.
Through the wire. Which way?
To the cathode.
To the cathode. And what is in the salt bridge? You want to do NaNO3? NaNO3. Where is the Na going to flow and where is the NO3 going to flow? So the iron, yes.
It's Na, not K.
Oh, yeah.
Do we have to do arrows or something?
Yes. Show which way they're flowing, yeah. Na. And this right here is 1 molar copper 2+ solution. Is that it?
Yeah.
So this is our E naught. The last thing is put it into perspective of your shorthand. So what's going to be the first thing we write? Fe. And then we have Fe 3+. And then we have Cu 2+ and Cu. Since this is in standard conditions, we don't have to write anything. But if our conditions change and say this is a 2 molar solution, you would see it written like that, where underneath they would put what the concentration is. So if it's not standard, if it's not an E naught, then you have to denote concentration. So we did anode, cathode, direction of the flow, ions, half reaction. I think that's everything. Any questions on how to draw those? And remember, these are voltaic cells. So in a voltaic cell, so there's something we call the EPA van. So in voltaic cells, the anode is negative. And we're going to talk tomorrow or next Thursday about electrolytic cells. And in electrolytic cells, it's a positive anode. So that's how to help you remember. But remember, we always flow from anode to cathode. Electrolytic is positive anode, and then voltaic is anode negative. All right, any questions? All right, you should not have any homework tonight unless you didn't finish it yesterday. So, and look, I lied to y'all. It was 24 minutes.